First of all, thank you very much, Julie. It's a great conference so far. We can see that it's dense. There's a lot to talk about. Two amazing presentations, and also a really nice chance to speak with the women from the Women in Architecture group. So I'm very excited. So what I decided to do is kind of revert. Maybe I didn't get the right memo, but I'm trying to kind of reverse the conversation and ask how do we see the immeasurable, and specifically how do we imagine a kind of a very different material world. I've had a long-standing love affair with materials of all sorts, and I have a very broad idea of what is material, which extends into program, into the dialogue that Anna mentioned between inside and outside. But I did want to offer one kind of definition, one framework for this idea about the change that I think we're in the middle of, which is a material evolution of a very significant kind. It has to do with the energy transition, but it also has to do with the whole set of materials by which we make things. And I think we're going soft, not in the sense of being senile necessarily, but looking at a new relationship, a new way of seeing things that has to do at its center with understanding nature, wild nature, technology, and the built environment as one spatial system. So this sounds, very, very simple, like, so what? But if you think about the consequences, I think that they're very challenging for architecture, and they're potentially very profound, because there is no away in this system, right? We can't throw anything away. There's no place that isn't part of this, and everything that we thought was nature is really a hybrid nature culture. This is a kind of an idea that Latour has talked a lot about. But that there is no pure nature anymore, and nor is there a technology apart from its environmental context and consequence. So I do have a kind of short period of time today, and I'm just going to focus on 4 projects that show different kinds of instantiations of the play between materials, technology, and nature. In this first project, the Tauser Anthropology Building, I want to talk about the kind of expansion that can happen when very simple, dumb materials, like bricks, for example, can come in contact and be organized with our digital networks through computation. So in the work of KVA MATx, a lot of what we do is try to look historically at older building techniques and take something that's actually quite ancient at times and expand its potentials digitally. And we do this in the framework of building. So for us as architects, the projects that we do are our medium for exploration. So here on this slide, you can see this building from 1971. It was Tauser Library. This is the Peabody Museum. We're on the campus of Harvard University here. And our task was to take this building and to save the footprint, to save all the steel, to save the concrete structure, but to remove the brick because there was mold damage, and to transform the kind of identity of the anthropology department. So we added 2 stories, and I want to talk in particular about this entry pavilion, which for us was a very kind of opaque, almost Mayan archaeological artifact. So what we did was to begin with the dimensions of a door, which you can see here. And since we had an existing foundation that we had to work with, we couldn't stray too far from that. But we could develop a system by which we could adjust the massing of this envelope with a global geometry and link in units tied to this geometry through computation, link in brick units. So I think that what this did was provide a pattern and a 3-dimensional expansion of the ancient brick technique of corbelling, and to do that in a way that wasn't necessarily aggregative, but that was holistically based on the form of the massing itself. So rather than being an applique or being postmodern, if you will, it was tied actually to the form. And if we were to adjust the form, we would have an entirely different pattern of brick. And what became interesting in this process of digitizing brick, of creating a kind of digitally organized brick, is that we then, of course, had to build it. That's always a consequence of architecture, or sometimes can be a consequence of architecture. So we worked with our local masons to develop ways of testing what our three-dimensional digital model showed, testing that against the actual reality, the slippages, the stacking, and the dimensions of the bricks that we were using. I think actually there's an image here of Eric Verboon on our team here, and you can see the kind of three-dimensional effect and the very unique patterns which are happening here on either side, actually, which are specific and appropriate to this particular massing. If we change the massing, the brick corbelling effect would also change. So you can see the way in which this catches the light in different ways. And there's a play of using a very contemporary wall system and which is, let's call it thin, and kind of thickening it up with this idea of a digital poché. And I'm just touching on certain parts of this building, but inside the building, there's a large light well, which you can see there above the second floor. And this light well is the lung of this building. It's a technical center. It's where air is exchanged. It's where daylight comes in, but it's also the social center of the building. And it's built around a geometry which has one awl line here, and it spirals up as the atrium turns to kind of catch more northern light. And I'd like to talk a little bit about the cladding that we developed for this light well. Using the idea of the graft. The graft is a kind of an interesting and sometimes disturbing phenomenon where two very different living things are deliberately brought together and they co-live together. And it's a form of augmentation. And so what we did with our team was to map out where regions where daylight would fall all the way around the light well, and also begin to map out regions where we would need acoustic attenuation, where we would need to absorb sound. And then we developed a method based on the kind of natural capacity of birch to both reflect light and absorb sound. So kind of augmenting the natural, seemingly so-called natural properties of the birch. And then we developed a very simple code by which we could take these panels and graft in slits using the algorithm and customize a panel, having more reflectivity or more sound absorbing material as we went. So we became very interested in this idea of augmenting, of actually going beyond what is nature. The next project, it kind of shows us that there's actually nothing more surreal, more unnatural than nature in some ways. This is a field of linen in France, and we did a very deep dive into natural linen on this project, which is called Climalin. And there we learned that all of these linen flowers bloom in one day. So there's a kind of an effect that propagates itself, and then it goes away. And so we were asked to work actually by the French government and a consortium of very traditional linen weavers who are using a very traditional Dobie flat loom here. That is Olivier Demestre there from Demestre-Lemaitre and some of his colleagues looking at the textile that we were developing. So our challenge was to try to create a new form of linen that would be augmented but still 100% natural. So, and I'm abbreviating our process here, but what we decided to do was to integrate phase-changing material into linen and to create a linen that could play with the kind of ambient wasted heat in our daily environment. And so we began looking at a number of different sources, which you can see here: radiators, car seats that heat up, casseroles in the kitchen, light bulbs that give off too much heat, and so forth. And with our manufacturers, we settled on a variety of different products that were exhibited this fall in Paris. And going forward are a curtain and a scarf, and I will show you the scarf here. So what we did is develop a way to integrate a microencapsulated vegetable-based phase-changing material directly into linen. And linen is super absorptive. It dries for a long time. Mummies were wrapped in linen. So it really soaks up the microencapsulated phase-changing material. And it's interesting what can begin to happen. So this being France, everybody enjoying scarves, and linen scarves being like an important kind of market segment for the manufacturers, we developed a linen scarf that you could absorb heat from the body. You could also charge it through just the daily gesture of putting it on your radiator. And as it began to heat up, the scarf material would change color according to how much heat it was received in these bands, which could be a little bit like the linen growing in the field, that are thermochromic thread that we wove into the linen. So we became pretty interested in the idea of a heat signature, that you could have a mass-produced element that could be done in great bulk, could be woven in great bulk, with the phase-changing material integrated, but each user, depending on their particular thermal context, would be able to generate a different pattern for this. And you can see my colleague Ben Widger here at KVA trying on an early prototype. I want to kind of take this idea a little bit further and ask you to kind of imagine a big transformation in all the materials that go into making an architecture. And to think about a sort of a bucolic image like this actually as a network of information, a network of ecology, a network of certain materials that obviously sort of have a relationship with one another. And this was the kind of beginning for us for a project that we recently completed in Germany for the Soft House. We won a prize. We're working with a very fantastic engineering team in Germany. And our project was to participate in the International Building Exhibit, which is one of architecture's oldest, kind of most venerable explorations of urban culture that take the form of a built work. So everybody in the IBA, and there were many international architects, was commissioned to build a built work which is now being lived in. So with the Soft House, we imagined a kind of a transformation of the timescales of the house and of the infrastructure. We imagined a very, very simple base that could be used for working. You could have your office in here, or you could rent it out as another apartment. And then a very simple two-story block, and generating electricity on site with a kinetic facade, and distributing that in the form of curtains and in the form of curtain tracks. So we make these very kind of dumb, simple videos to kind of explain to ourselves what it is that we're trying to do. And yeah, I think it has to play through. Forgive me for 1 second. Yeah, you can see that, that the twisters are moving to the east and to the west. The house is facing south. And as it moves through, these various different patterns are made from this very, very simple kind of facade idea that user interface and that movement as this tracks the sun will be the thing that will actually kind of produce the affect of the facade. So that this one building has many different ways of looking and being, depending on where the sun is and whether people are opening or closing the sun for views. So our proposal was to actually try to create an active house, a house that was networked and that was responsive to its exterior environment. And at the same time, we were asked to make this housing project be a certified passive house, So that was a little bit challenging because we had to meet all of the German passive house criteria while exploring this new idea about being active. So for the construction of the house, we kind of went back in history and recovered the idea of all-wood construction, which was once very popular in Germany. But after World War II, in the Reconstruction period, Germans moved away from wood and they wanted concrete and they wanted steel and glass. They wanted all of the kind of material culture of modernism. So we proposed a kind of a revival of this very simple technique where you take softwood, you stack it up, and then you take a hardwood peg and you peg join these panels. And as you put the hardwood in the softwood, there's a biojoint, a bioreactive joint that forms naturally. It locks tight, and there are no screws and no glues in this system. It can be 100% recycled, and it sequesters, of course, a ton of carbon because it's solid wood. You can see the 4 units on a truck can be made very locally by smaller entrepreneurs and manufacturers, which I think is important. So you need less factory work. Comes to the site, gets erected relatively quickly, and all of the materials in this architecture were kind of materials taken from that natural network. This is the insulation material, which is a sheep's wool material. So I want to talk a little bit about the interior of the soft house. On the image, you can see the twisters. These are harvesting energy. And inside, there is a way in which that on-site energy actually can move into the house along curtain tracks. And these yellow objects that you see here represent the curtains. So I'm going to spend a little bit of time on this. You can see that we developed a way of dislocating the infrastructure, because when your wall is solid, you have to completely rethink the wall. And when an architect rethinks a wall, essentially, that's a very big, very significant cultural shift. So we migrated all of the electricity out of the wall and made it configurable and put it on the ceiling. This is actually not a power inverter, it's just the power connection to the twisters that you can see outside here. And this is all direct current power, DC power. So no need to have those losses by converting the power into AC or into a higher voltage. And you actually gained about 15% more from your solar investment, according to Bureau Happold, who were our engineers. So this is a little weird for me, but I'm going to show you people living inside the soft house. This is their birdhouse. And it's kind of strange for an architect who's made an experimental project to kind of actually see how the place is inhabited. You can see the light well down to the lower floor. These people are cooking. They are using their downstairs as a kind of a kitchen, and their office is on the second floor. There they are. And in a minute, you'll see how they kind of move the curtains to make space, going from a traditional curtain to a kind of a privacy curtain that gathers around their bed. And then you'll see here it's the twisters. This is a marine technology. It's a boat winch that we used. It's on a servo drive. And this little time-lapse piece just shows the way in which this is constantly tracking east to west, as well as north and south. So to my knowledge, it's really the first soft 2-axis solar tracking system. So I have 2 more projects. I'm going to show them very quickly. I want to talk about this idea of a network and make this maybe a little bit more political, about how elements of nature, like wind or currents or water, can become actors in an architecture, how an architecture might actually give voice to elements of nature. This is a project in Manhattan, the East River Public Ferry Terminal. We did this with the New York City Economic Development Corporation, the Department of Transportation and Parks. And so this is a kind of very hardcore client group, if you will, for innovation, I won't say innovation adverse, but unlike Germany, this was not a group that sought to make changes really in the ferry system. So the first thing that was interesting about this site was that we realized that there's an enormous estuary right here to the north, and the flushing, the kind of movement of water through tides on the East River out to the bay and back is one of the key things that keeps the freshwater system around Manhattan healthy. So in this project, we tried to reveal and express that. And we were fortunate enough to be able to tie into a GPS system and to tie into a number of internet and passenger wayfinding digital layers, digital networks that are sort of ambient in the city. And even though these digital layers are very present at this site, it is also, it is also a part of nature, because there is no outside anymore. You have wild nature as much as you have wild nature as much in the city as you would have an urbanism in what you might consider to be wild nature. So what we did is we thought about the direction of the water moving, and I'm sorry this is so light, but you'll see that water is moving. The current moves at a certain speed, and that speed changes according to the tide and the moon. And then when ferry boats arrive and people move through the system, we wanted to kind of be able to see or record those flows as well. So there's sort of two ideas: the movement of the movement of the water and the movement of the people. The ferry station has been very, very popular, and it has catalyzed quite a bit of development in the area. And you can see the LED systems here, which are located in these large daylighting wells. And these LEDs are programmed to reflect the movement of the water. You're probably not going to be able to see this video. Oh, you can see it a little bit better. This is how that is done. You can see the speed, how it hits the LEDs, and you'll see some purple scratches in a minute. That's the kind of energy that's put into the system when people walk through it. So just with a very simple device, a circle of light, we can begin to give voice to a much more complicated natural phenomenon. This is the last project I want to talk about. It's also on a river. It's on a big river as well, the Amazon River. The Portable Light Project is a nonprofit research and design project that we've been involved with for quite some time. And I'm going to focus right now where that brown dot is in Brazil. So we're going to be talking today about Luz Portátil Brasil, which is the Brazilian implementation of the Portable Light Project. And we're working actually on two rivers, the Arapongas and the Tabajos, which are very, very important river branches from the Brazilian Amazon. So this is a very simple idea about dematerializing infrastructure, and instead of making it furniture-like, like the soft house, actually making a portable system. We're thinking about the materiality of photovoltaics. These are CIGS panels. We did not invent this technology, but we did invent this way of harvesting actually 5 of these in a single panel. So in a way, we tricked, I think it's fair to say, we tricked Global Solar. When they sold us one panel, we actually were able to use it for 5 different things, 5 different panels from the way that we had them wire it for us. So that made it much more affordable for us. And this is the basic kit. These are the flexible solar panels. We have a very simple high brightness LED. We have a button, on, off. We have a USB port, and you can charge a cell phone. So it's as simple as that. A very small increment of power that's used to provide renewable light and charge a cell phone. But the interesting thing is that this entire kit that I just showed you can be integrated in this. It can be integrated into a textile. And in the Portable Light Project in Brazil, we looked at how those textiles could be adapted to local textiles that were available in Brazil and made by a team of local sewers. So this is a very ambitious project. We did this with the IADB and also EDP, which is an electrical utility company in Brazil. And we're really trying to question the distribution, the prevalent distribution patterns in manufacturing, which are primarily east to west. So usually when things come to Brazil, like batteries or solar panels, they come from China. And we are trying to think about something that would be a little bit less carbon intensive. There would be a hub in Sao Paulo. There would be a short flight up. And then we have the solar panels made in San Luis Potosi in Mexico, and they arrive to Belén, the Amazon port. So it's a north-south kind of Southern American manufacturing chain. These are the sites that you can see here where we have portable light villages, pilot villages on the Amazon. We're working, I think, with 13 different villages. And then this is the kind of setup. It's much more urban than you might think. You think about the Amazon as a kind of a place where, from Hollywood, where anacondas are and things like that. And actually, this is one of the most rapidly developing areas in all of Brazil, which is, of course, a big, big problem. And there are all kinds of materials like styrofoam and kerosene that, that don't mix well with water, and they don't mix well with people. So the Portable Light Project is really about replacing the kind of fossil fuel-based lighting with a flexible and adaptable light that can be folded flat and bent up into shape and used. And what was interesting about this project was that we worked with Copa Roca, which is a women's makers group here, and they created all of the portable light textiles for these women here in the north who are the users. So for the first time, you have the producers of energy and the users of energy who are benefiting. And this is the actual shape of the kit that is flat here, folds just to this footprint, and then opens out like this as a reflector. And you can see these women beginning to learn how to fold up and use the portable light kits. And what became interesting was the sort of unpredictable power that became local when you could charge a cell phone anywhere in the forest or on the river and also have some light. And one of the things that emerged were a series of workshops using kite mapping. We used MIT's Public Labs Kite Mapping, which is a free software, which allows people to make very high resolution aerial photography by hoisting their charged cell phones up with a kite. And that aerial photography is used by the local people to prove that they own that land, and also to keep track of their small agricultural businesses. This is the president of one community, and she's photographing her bee enterprise. She has a honey enterprise, and then she can use various different free software like Panoramico and so forth to geolocate those images and, for example, show the Brazilian government what is happening on the ground so that she can continue to get her green grants, which are important to these people. So for economic development, portable light is being tested in these communities. And I just would draw your attention to this kind of network where we have the vehicles, like physical movement. We have all of these different things, cashews, bees, fishing, sustainable fishing, and so forth, and portable light, and that you can go by boat, go to the NGO's center, download your information from your cell phone, and with this suite of open source free apps and free software, begin to develop rights to your own property, which is necessary and hadn't been able to have been done before. So we're trying to close a gap between the kind of global view of the network and what happens on the ground. Thank you.